Have you ever imagined driving a car through the bottom of the sea, from one country to another, in just 10 minutes? It sounds like something from a science fiction movie, doesn't it? But right now, in the chilly waters of the Baltic Sea, a massive team of engineers and thousands of workers are making this dream a reality. They are building a giant concrete Lego set beneath the waves. This is the story of the Fehmarnbelt Tunnel, an $8.7 billion project that will physically connect Denmark to Germany, and with it, all of Scandinavia to the rest of Europe. It is one of the biggest and most complex engineering puzzles our world has ever seen. But why go through all this trouble? What makes this project so special that countries are willing to spend billions and face incredible challenges to build it? Today, we will explore the complete story of this underwater giant, from the very first idea to the final day when cars and trains will race through its concrete tubes. To understand why this tunnel is such a big deal, you first have to look at a map. For thousands of years, the Fehmarnbelt, an 18-kilometer stretch of water between the Danish island of Lolland and the German island of Fehmarn, has been a natural barrier. If you wanted to get from Copenhagen in Denmark to Hamburg in Germany, you had two choices. You could take a long drive west, going all the way around the sea, which added hours to your trip. Or you could take a ferry. The ferry ride itself takes about 45 minutes, but when you add the time for waiting, boarding, and unloading, a simple trip between these two major cities could eat up almost 5 whole hours. As Europe grew more connected, this slow link became a major headache for travelers and businesses alike. The idea for a fixed connection, a bridge or a tunnel, had been talked about for over a century, but it always seemed too expensive, too difficult. The water here is deep, the weather is rough, and the seabed is made of a tricky, soft clay. It wasn't until the early 2000s that Denmark and Germany finally sat down and said, "Let's do this." In 2008, they signed a treaty, officially giving birth to the Fehmarnbelt project. The goal was simple but incredibly ambitious: to build a direct, fast link that would stitch Europe closer together. Now, you might be thinking, why a tunnel? Why not build a spectacular bridge instead? Bridges are often cheaper and faster to build. Initially, a bridge was actually the preferred option, but as planners dug deeper, they ran into two huge problems. First, the Baltic Sea is a superhighway for massive cargo ships, including tankers carrying oil and other dangerous materials. A bridge would require enormous towers and support pillars. If one of those giant ships ever lost control and slammed into a pillar, it would be a catastrophe. Engineers said they could build the bridge to withstand a crash, but the risk was still terrifying. Second, the environment played a major role. The Baltic Sea is a very sensitive ecosystem, and a bridge with its many pillars would change the water flow, potentially harming marine life. There was also the weather to consider. Strong winds in the area could make driving on a high bridge dangerous, sometimes even forcing it to close. After years of debate, protests from environmental groups, and careful study, the decision was made. The only safe, reliable, and environmentally responsible choice was a tunnel. But not just any tunnel. They decided to build the longest combined road and rail immersed tunnel on the entire planet. The word immersed is the key to understanding this whole project. This isn't like the Channel Tunnel, or Chunnel, between England and France, which was drilled through solid rock deep beneath the seafloor. The Fehmarnbelt Tunnel is being built in a completely different way. Imagine you're in a bathtub. You don't dig a hole under the tub, you just sink a toy boat to the bottom. That's the idea here. Engineers are building a giant factory on the Danish coast. In this factory, they are constructing 89 enormous concrete segments, each one a massive, hollow box. Each of these 89 elements is a whopping 217 meters long. That's longer than 2 football fields laid end to end. They are 42 meters wide and 9 meters tall. To give you an idea of the scale, each single element weighs a staggering 73,000 tons. That's heavier than 10,000 full-grown African elephants. Once a section is finished, they will seal its ends with giant watertight doors. Float it because concrete can actually float if it's hollow, and then tow it out into the Baltic Sea. Using a specially built ship, They will then carefully lower each 73,000-ton monster into a pre-dug trench on the seabed, 40 meters below the surface. Once it's in place, they will suck the water out of the chambers inside, and the element will settle firmly onto the bottom. Then, divers and robots will connect it to the previous section with a precision of just 15 millimeters, using a special system of guides and clamps. It's like building with the world's heaviest, most expensive Lego set, in the dark, under tons of water pressure. So, how do you even begin to build a tunnel this way? The story starts on land, at what is now being called Northern Europe's largest construction site. In Rødbyhavn, Denmark, a massive industrial complex has risen from the ground. It covers an area bigger than 200 football fields. This is where the magic happens. They've built a huge factory, not to make cars or electronics, but to build a tunnel, piece by piece. The process is like a perfectly choreographed ballet. First, massive steel reinforcement cages, the skeleton of the tunnel, are put together. Then, these cages are pushed into enormous molds, and concrete is poured continuously for 24 hours to create a 24-meter-long segment. They do this over and over until 9 of these segments are joined together to form one complete 217-meter tunnel element. Because the schedule is so tight, they have 5 production lines running in parallel, churning out these concrete giants like a hyper-efficient assembly line. Once a full element is cast, it needs to be moved from the factory hall to a giant dry dock next door. But how do you move something that weighs 73,000 tons? You can't just put it on a truck. This is where some of the most clever engineering on the project comes into play. The massive concrete block rests on special skates and beams. A team of hydraulic jacks, controlled by computers, grabs onto the element and pushes it forward, inch by inch. It's a slow, careful process, moving at just 10 meters per hour. Think about that. It takes an entire day just to move one tunnel element a few hundred meters. And they have to be incredibly precise. If the element tilts even a tiny bit, the stresses could crack the concrete. Computers monitor everything, using sensors to ensure the giant box stays perfectly level as it inches towards the dock. Once it arrives at the dry dock, the doors are sealed and the basin is flooded. Then, just like a ship, the massive concrete box, weighing as much as a skyscraper, floats for the very first time. But while the construction on the Danish side is a marvel of modern industry, the project has faced a storm of challenges, especially from its southern neighbor. In Germany, the tunnel has not always been welcome. Environmental groups like NABU fought the project for years, taking their case all the way to Germany's highest federal court. Their concerns were serious. The Fehmarn Belt is a protected area, home to rare harbor porpoises, which are very sensitive to underwater noise. The construction, especially the dredging of the trench on the seabed, and the noise from construction vessels, they argued, would harm these animals and cloud the water with sediment, destroying their habitat. For a long time, these protests held up the project. The German approval process was a maze of regulations and legal battles. It wasn't until 2020 that the final legal challenge was dismissed, and construction could officially begin on the German side. The project owners promised to be careful, using special bubble curtains to muffle the noise of underwater work, and creating a massive new nature area on reclaimed land to make up for any damage caused. There were also concerns from local German communities on the island of Fehmarn. This region's economy relies heavily on tourism. People come for the quiet beaches, the calm sea, and the small-town charm. Many locals fear that a massive new tunnel, pouring thousands of cars and trains directly onto their island, will destroy that charm. They worry about noise, traffic jams, and the industrialization of their peaceful home. On one side of the border, the Danish see jobs, growth, and connection. On the other side, some Germans see a threat to their way of life. It's a classic story of progress bumping up against tradition, and it shows how building a mega project isn't just about concrete and steel. It's about people, politics, and the environment. And just as these battles were being won, a new, even bigger problem emerged. The project, originally supposed to open in 2024, then pushed to 2029, is now facing a serious delay, not from protests, but from a ship named Ivy. Ivy is not just any ship. It is a one-of-a-kind, custom-built vessel designed specifically to lower those 73,000-ton tunnel elements into the sea with millimeter precision. It's a floating engineering marvel, packed with complex computer systems, GPS thrusters, and giant cranes. Because the tunnel elements are so heavy and the water is so deep, no ordinary ship could do the job. Ivy is the key to the entire operation. Without her, the tunnel elements just sit in the Danish harbor, unable to be placed. And Ivy is having problems. She is a prototype, a machine that has never been built before, and her complex mechanical and electronic systems are taking much longer to test and approve than anyone expected. As of late 2025, the completion of the special vessel is a year and a half behind schedule. The company building the tunnel has admitted that, with this delay, it is now difficult to meet the 2029 opening date. For the first time, the world realized that this incredible project, this underwater Lego set, might not be finished on time. The delay with the ship Ivy sent shockwaves through the project, but it wasn't the only headache. As with any story, there are always twists and turns you don't see coming. The contracts to build the tunnel were signed back in 2016, a lifetime ago in terms of world events. They were signed before the COVID-19 pandemic disrupted global supply chains. They were signed before the war in Ukraine caused energy prices to skyrocket. And crucially, they were signed before the full extent of Germany's strict environmental rules became clear. These old contracts didn't account for these new realities. For example, German regulations on underwater noise from construction vessels are very strict. The ship Ivy, already delayed, now has to meet standards that were not even fully known when she was designed. This makes it incredibly hard to speed up the work later to catch up. It's like trying to run a marathon in heavy boots while carrying a backpack that keeps getting heavier. The team is in constant dialogue with German authorities, trying to find practical solutions. But it's a slow and difficult process. And there's another piece of the puzzle that's causing concern, and it's not even under the sea. Remember, the tunnel connects the island of Fehmarn to the German mainland. Right now, there's a road bridge that does the job, the Fehmarn Sound Bridge. But for trains to reach the new tunnel, and to handle all the new road traffic, that old bridge isn't enough. Germany needs to build a brand new 2.2-kilometer-long road and rail tunnel to connect the island of Fehmarn to the mainland. This is a massive project in its own right. The problem is, this connecting tunnel hasn't even been fully approved yet. And Germany's national railway company says that once they get the green light, it will take them 6.5 years to build it. 6.5 years. If you do the math, even if the main Fehmarn Belt tunnel under the Baltic Sea is finished in 2029, trains might not be able to use it for years after that. Cars could still drive onto the island using the old bridge, but the full potential of the link, the high-speed trains connecting Copenhagen to Hamburg in under 3 hours, might not be realized until 2032 or even later. It's a classic reminder that a mega project is only as strong as its weakest link. So, with all these delays and challenges, why are they still pushing forward? Why spend billions on something so difficult? The answer lies in the future. Once this tunnel is finally open, it will transform Europe. Picture this. You get in your car in Copenhagen. You drive for a bit and then you descend into a tunnel. For 10 minutes, you're driving under the Baltic Sea with 40 meters of water above your head. When you come back up, you're in Germany. A trip that used to eat up half a day now takes less time than a coffee break. For a train passenger, it's even faster, just 7 minutes from Denmark to Germany. This will slash the train journey from Copenhagen to Hamburg from nearly 5 hours down to just 2.5 hours. It will create a high-speed link between Scandinavia and the heart of Europe, making it easier for people to visit, for businesses to trade, and for cultures to mix. It's also a project built for a greener world. The tunnel will have an electrified high-speed railway. By shifting both passengers and heavy freight from planes and trucks to electric trains, it will cut down a huge amount of carbon pollution. The European Union believes in this project so much that it has given over $1 billion to help build it, seeing it as a vital piece of a green transport network for the future. The tunnel will be paid for by the users, with tolls from cars and trucks. and it's expected to take about 40 years to pay back the loans. It's a long-term investment in the next generation. When you look out at the Baltic Sea today, you just see water. But beneath the surface, a new world is taking shape. Despite the delays, despite the protests, despite the impossible engineering challenges, the tunnel is being built. The factory in Denmark is running 24 hours a day, churning out those giant concrete elements. King Frederick X of Denmark has already visited and unveiled the first completed section, a proud moment for the thousands of people working on it. One by one, those 89 pieces are being made. And one day, hopefully soon, the ship Ivy will be ready. She will sail out, pick up these massive blocks, and gently place them on the seabed, one after another, until the two sides are connected. The Fehmarnbelt Tunnel is a testament to human will. It shows that even when nature, politics, and physics stand in your way, we have the courage, the creativity, and the determination to keep building, to keep connecting, and to reach for a future that is closer, faster, and more united than ever before. It may not open in 2029 as planned, but it will open. And when it does, it won't just be a tunnel, it will be a new gateway to Europe.